Usual, it is a mixed bag of things, but I think also as we move closer to your exam date, it might be that you guys let me know um, for the next session um, if there's anything specific that we also need to focus on. So let's start with this one. Let's see how far we get this morning. Okay, so we're kicking off with solve systems of equations. Again, some of your calculators allow you to be able to do this. I know my HP don't, so I will need to do this the normal way of trying to get a solution. Um, Also, nearly before we even work it out, let's just look at what options they give us. So you look at a 6, a 2, a 0, a 0, 6, 2, 2 zeros. So this already tells me a bit of our solution in the end as well. So if we work out our first one and suddenly now we get x is equal to 5 or 7 or something like that, it might be that we need to relook that first solution already. Okay, so let's see what we can do with this. We've got, if I look at this one, we've got two things. So we will be able, if we manipulate that, maybe get rid of the x's so that we only have a y and z, and then we have a y and z here. So that will be a nice one to basically check. So I'll do that first, that we manipulate 1 and 2, and then whatever we get out of that, we will work with the third equation, and that will give us over y over z. So let's write that first equation down. If you guys see any other possibilities that might make it easier, please say. But at the moment, this looks like a nice one to say, okay, if I take the first one and I subtract the second one, I can get rid of the x's. So x minus x is 0. Y minus 3 will give me plus 4y. Z minus nothing will just give me z. 8 minus nothing will give me 8. Okay, so there I have my new formula. Then I take the one that I saw there, so the 5y minus z is equal to 10. That was my third formula, and I can just say, well, if I now add the two, the z's will disappear. So if I say formula 3 plus formula 4, I will get something that I can work with. So 4y plus 5y is 9y. Plus z plus minus z is 0. 8 plus 10 is 18. So I can get that y is equal to 18 divided by 9 is 2. Okay, so that was for me nearly at this stage the easiest to work that out. So then I will quickly check first. So there's a y2, y6. No, that's wrong. y0, so that's wrong, y2. So at least now I'm working with two options. That's possible. So then I would again check which one of these only has a y and another one. So let's quickly see. I will use option 2. So let's put in y there. So x minus 3 times 2 is equal to 0. So there, let's just see x minus 3. We've got the 2 in there, 0. So x minus 6 is equal to 0. So x is equal to 6. Okay, so that then again gives me, I look at that, there's x6 and then the other one. And so now we are basically, we have option 1 as our answer, but let's just make 100% sure. And let's just put in what it's needed to get the z as well. So we can use that third equation to put in z to get z. So y was 2 minus z is equal to 10. So minus z, and that is 10, so 10 goes over. So 10 minus 10 is equal to 0. So z will be equal to 0. And there we have it. Okay, so for the exams, if you don't have any of those calculators, like I also don't have one of those where you can put in the formulas, this is probably the easiest way to work it out. While you guys are studying and getting these and you struggle to work it out, again, I will load this calculator for you guys again, the link onto it, because again, if you're struggling with it and you want to see quickly, there is this nice link from a website that you can use. Well, you can't use it in the exam, but you can use it to practice and see where you might have made a mistake if you're not getting it, or you want to see the steps. So if we quickly put that in, and there you can see the answer as well. So it's exactly the same. And then, as you see, they show us exactly all the steps that to work it out. Okay, so I will post this link again into the chat, that you have it. What I will also do is I will put it into the presentation. So when I share the presentation today, you will have it as well. So it is in the notes component. Okay, so let's go to the next one. So this one I thought was an interesting one. So first of all, let's read through it, and then in the chat you can also tell me what you would have done if this was the exam question. So an investment in a bank grows according to this formula, where T is the time in years and P is the amount invested, amount plus interest. After how many years to 2 decimals will the investment be equal to 4,000 Rand? Okay, so what would you guys have done in a question like this? Because it is a bit of a trick question. So if anybody has any idea, else I will in any case quickly show you guys. So let's just read this again. So you get that formula. So they tell us T is the time, so we will need to work out the time. When they say P is the amount invested plus interest, after how many years will the investment be equal to 4,000? Okay, so a lot of times when we see a question like this, we suddenly think integration, differentiation, or all those things. But yeah, we actually just need to work out the value of T, where they give us all the information of the rest. So they tell us what the investment will be. We just need to work out what the value of T will be. So it's not a change over a year or anything like that that we suddenly need to do any kind of differentiation or integration or anything like that. They want us to get to that value of T. What makes it also then a bit difficult is we've got e to the power of. So then that means we will need to or take a log or do something else with it. Okay, so first step for me is when and let me move this so that we just have enough space. So I'm just going to put it up there, and then we can get. So the first thing I will do is get rid of what is beneath the line. So my first step will be to say 4,000. We will multiply that out on both sides. That will be equal to 6,000. Then the next step, because we need to isolate that T, is nearly to get rid of the 4,000. So we will need to divide the 4,000 on both sides. So again, it's not a quick way to get to the answer, but then still need to isolate this component. So first, then we will need to say get rid of the 1. So we will subtract with 1 on both sides. So then we left with this component. So let's just make that clear. It's 4. Okay, so let's already just say 6,000 divided by 4,000, but I can work with numbers. So subtract Then we need to get closer to that t, so then isolate this component. So we will need to divide on both sides with 29. So then we get very much closer to this component. So 1.5 minus 1 divided by 29, and I am already now going to say what that fraction is as a decimal. Okay, so as we move closer, now the next step is to say we take the log of each one. Okay, so where was that? Chapter 2 or 3, I think, in your study guides where we looked at logs and what we can. I think it was around study unit 2 and 3, where we talked about logs and those kind of things. So if we take log on both sides, just want to check. And so what we left with is 0, was t, and then log or ln of, and again, on your calculators, on mine it's ln, but log is exactly the same. So if you have log on your calculator, it does and is exactly the same function. So 0.01724, and the log of that is minus 4,0605. So to isolate t, I need to divide by minus 0.4. And then my answer will be 10,15. And let's just check. It is option 1. Okay, so this one, I specifically included it because a lot of time we see something like this where you've got the exponent nearly underneath, and nearly the first thing we nearly always want to do is to say, oh, that looks like that differentiation thing where we have a term above, 2 terms at the bottom. We need to do something with that. But in this question was actually much more straightforward in what we needed to do, but then in how to get to the answer, it is quite a lot of work as well. But then we get to how many years it is 10.15. And again, you can actually, when you get that, so what you guys could also do, and that is, again, how I call it my shortcut method, is if you are really stuck for time, you don't have a lot of time to work this out, put in those numbers in the T. Work out that and see if you get 4,000. That you can also do. So remember, it is multiple choice survey, we're not going to look at your workings or anything. So if you pressured for time, put that 10.15 in. Luckily, that was now the first one, but put that into your equation and see what you will get. And it should be the same. So if it now was the 10.15 at the bottom, yes, you work through 4 options, but it is most likely still going to take you quicker to put that numbers in than to go through this process. So if you have 3 minutes left in the exam nearly, and this is your last question, there is always okay, what is this? Okay, so there's, I'm going to take that out. I don't have the faintest idea what the, what the question was. Okay, so talking about integration, differentiation, here we have a integration that we need to work with. So again, the first thing I will do is to just first simplify this and not work with 2 terms. This one is the easier one to say, let's first simplify this. We don't need to work with 2 terms, so let's multiply that in. So x to the power of 2 times 1 is x to the power of 2. If we say x to the power of 2 times 1, we get x to the power of 2, and that is over x to the power of 2. So actually, that comes down to being 1. And now this is a much easier equation for me to now work with for integration. So definitely for me much easier to work with this one. So now we follow the integration rules. So x to the power of 2, so we know what we need to do is say we plus 1, and then we will divide by whatever is there at the top. So x to the power of 3 divided by 3. So that's cool. So let's then, before we even work out the rest, x to the power of 3 divided by 3. X to the power of 3, there's no divide by 3. X to the power of 3 divide by 3, cool. X to the power of 2, so that's actually just what we add there. X to a, so by just looking at that first term already, we know the answer, but let's go on. Okay, so 1 becomes x. It's x to the power of 1 divided by 1, so we actually just have it as x. So let's just make sure there it still is, and then remember we don't know if there was a constant, so we always just add the c to the formula or to the equation because we don't know if there was a constant or not. So then we just need to add that. So option 2 is our final answer. But once again, it's much easier to simplify before you start your integration, because else you make it very difficult. You will probably get the same answer, but you do make it very difficult in the sense when you want to integrate with this instead of the simplified version. Okay, let's go to the next one. And again, just remember, I will later today post the recording and the presentation onto our WhatsApp group, and then also in probably later today or tomorrow, I will put up a poll again for when next week we can have sessions again. Okay, so let's get into consider the market defined by the following functions. You've got your demand, you've got your supply, and they ask us where P and Q are the price and quantity, calculate the equilibrium price and quantity. Okay, so what must we do in this instance? Okay, so we've got a P and P that is the same. So I will start by saying perfect. We set them as equal to one another. So 60 minus 0.6Q. Let's just make sure that I don't make a mistake. And 20 plus 0.2Q. Let's just check this one. So probably if I look at this, I will most likely, just by getting the Q, you can see 20, 30, 300, 200. By just working out Q, I will already have my answer. And very much so, again, nearly tips for you guys, because they give it to us as P is equal to and P is equal to, work out the Q's first. If I said in this instance, let me just rewrite it a bit. Okay, so let's see if I can rewrite this. So if I've given it as in the, so they could have rewritten that as something like that. So then just check what is the easiest, to change that one that we get a Q, or to multiply out and to simplify. So it's not always that they give us it nicely as to say the one is P is equal to, the other one is P equal to. So if there's a bit of where one is Q is equal to 10, I'm now just making something up. Just make sure then that when you simplify, you don't now say that one is equal to that one or something. Just make sure then that you are working on both sides with a P, or you're actually working with a Q. So just in this instance, it was awesome. They gave us both as P is equal to. So then we can just go straight forward and do this. Okay, so let's take all the numbers to that side. So 20 becomes minus 20, so 60 minus 20
is 40. We take a minus 0.6 to that side, it becomes positive. So positive 0.6 plus that is 0.8. So that is 0.8 Q. So if I then say 40 divided by 0.8, now I must see if I've actually done this correctly, because I get a different answer. Don't tell me now it's none of the above. Let me just 60 minus that, because I now get Q is equal to 50. So let me just make 100% sure. 60 minus 0.6 Q, 20 plus 0.2 Q. So if I take that over 60 minus that is that, minus 0.6. If I take that over, it is 0.8. Now, okay, so if anybody else can just check for me as well, then I would put that 50 back into that one, the 0.5, sorry, 0.6 times 50 is 50, so 60 minus. Okay, so I'm not worried that I missed something. It seems right. Hmm. So then it would have been none of the above, but you guys, I think they've taken that hopefully away. Yeah, so if you work it out and you get something different, please let me know if I now made somewhere mistake in this. 60 minus 0.6 Q, 20 plus that. So that is 0.8, that is 40. And then 40 divided by 0.8 is 50. Okay, so I'll just quickly. Cool. So I hate it when it's none of the above, because one, I always then think I made a mistake somewhere. So I just want to check in some of my other, I just always get a weird feeling when it's something like that, but seems like it is right. So yeah, I never like it when we do something like that where it is none of the above. Um, and please tell me that they've, in your mock exams and your assignments, were there any questions where there was still none of the above? Because that also nearly sometimes, like it now triggers me to nearly question if I did it correctly. So hopefully, okay, cool. So yeah, so you can see this is from way back, previous exam papers that was put together. So I will just again make 100% sure that what we have here is the correct one. Okay, another question, um, and let's just quickly see. so we've now done the X, Y, Z where we need to work, well, where we need to work things out. This one is a bit different. So this one, they give you the question about, you need to look at what is the intersection of the two lines. Okay, so, and with the intersection of the two lines, what we basically need to do is to say, what is that point? So, like we did in the previous one, we will need to nearly say, okay, we need to work out the X, we will need to work out the Y. So, and luckily, as you can see in this one, they say, yeah, okay, 2x plus y minus 5 is equal to that. So normally what we will do when we get straight lines is we will say, okay, that first one, it's actually y is equal to 5 minus 2x. So if you guys remember the straight lines, and then the second one, we will say, okay, there's a minus 2y is equal to minus 3x plus 4. Okay, so that is if we working with straight lines. But then we will also normally say, okay, that we don't work with a minus 2y, so we will need to change that and divide everywhere by minus 2. So then it actually becomes 3 over 2 x 4 divided by minus 2. Okay, so then now suddenly we have two straight lines, and then we can say, well, now I've got the two y's, so I can say 5 minus 2x is equal to 3 over 2x minus 2. And then now we can actually work out x. So we can say that minus 3 or 3 over 2x go over to this side. So we on this side we now have actually minus 3 and a half x. On the other side we've got minus 7. Okay, so that actually works out very nicely that x is equal to 2. Okay, so there we have at least the x equal to 2. So, and then put it into the easiest formula. The y is equal to 5 minus 2 times 2, which will give us equal to 1. Okay, so that is one way we could have done this. Another way is sometimes a bit easier, is we're still working with the two different equations. So instead of having now 3 equations or 3 variables in it, we can still say, but let's work it out as 2 different equations, and we simplify, we change it. So the easiest again for me is to say, okay, here's a minus 2y, there's just a y. So if I multiply that first one with 2, I say that first equation times 2, I get 4x plus 2y. So this for me is actually a simpler way than doing that. Minus 10 is equal to 0. Our second equation, we just write over again. And then I say, oh, well, cool, that plus that. So 4x plus 3x is 7x. Plus 2y minus 2y is 0. Minus 10 plus minus 4 is minus 14. That's equal to 0. So 7x is equal to 14. X is equal to 2. Get exactly the same answer. This feels to me a much simpler way of doing it. But again, you're allowed to use both. So again, that for me is, it's not always needed to go this, and let's use the words, traditional route of, okay, I've got my Y, I've got my X, I need to put it, it's the straight line, so we need to get it in the right format. You can actually work with it a bit differently to get the same answers. Okay, so let's go to the next one. Okay, so let's first see, what do they ask here? A retail store sells a product at a price of R3.10 per unit. If a total cost of wholesale purchasing X units is given by this, approximately how many units should be sold to break even? Okay, so we will normally look at break even as where total cost is equal to total revenue. That is where we normally would say it's break even. So you're not making profit, you're not making a loss. So your total cost is equal to your total revenue. So for me, I would have said, okay, they give us our total cost function. It's just before I write that as an X. And then they tell us we will sell it for 3.1. So my total revenue will be 3.1 times X. Okay, so again, just out of the total cost one, you can see here, that's your variable cost, that's your fixed cost. So the total cost function also here does show you both the fixed cost and the variable cost component. Okay, so then let's just simplify. So 300 is on this side. I'll take the 0.92 over the 3.1 divided by 0.92. Wait, I made a mistake. 3.1 minus 0.92. So I get it as 2.18x. And then to get x, I must divide on both sides by 2.1. So 300 divided by 2.1 is, I get 136 0.61. And then we say approximately, so I will round that up to 138. So they will also not now in your exam give you 137, 136, and 138. So it will be a clear cut that it will only be one number that is rounded up. So they definitely not now in the exam will give you 2 or 3 options that are like one number apart from each other. That will just not happen. Okay. Okay, so this was more to look at the break even between total cost, total revenue. And I think sometimes what they might throw in is a theory question, because what we've now done is, where's that previous one? We did equilibrium, and equilibrium is always between the demand and supply function. And now we did break even, where break even is always between cost and revenue. So I think just remember those two, because I have seen, and I will check if I have a question like that, where they specifically ask a theory question where they said, when you're working with demand and supply at the point of intersection, do we call it equilibrium? Do we call it break even? Do we call it something else? So then they list a few things. So that for me is just nearly a reminder for a theory question that can look at these two terms. Okay, then nearly like we did with this one, where we worked out that point of intersection. Again, they do that, but now they've given us the two lines a bit differently. So we can still go back and do it the other way, but now that I'm working here with a 3/4x, then sometimes I just don't want to do it the other way. So I will change this formula, and then hopefully something will cancel out. But we can already see in your answers there's going to be a fraction somewhere. So unfortunately, we're not going to get away with this one where we're not going to have to work with a fraction. And yeah, I don't like fractions at all, because that is where one can easily make mistakes. Okay, so let's just rewrite it in the form as y is equal to. So first, that is minus 2y. The x goes over, the constant goes over. So what I will also not recommend is to go from this stage directly into now saying y is equal to, because then also one can sometimes easily write something wrong. So I will first, and it's just one extra step, just rewrite it as is and then simplify it. Okay, so then if we simplify and divide everywhere by -2, we get, so -3 divided by -2 is 3/2, and -3 divided by -2, again 3/2. And just remember, minus divided by a minus gives you the positive, and that might even make it that one of these others might even have been the correct one if you made a mistake with the signs. Okay, so now we've got 1y is equal to that, the other one, so we can say 3 over 4x plus 6 is equal to 3 over 2x plus 3 over 2. So we've got a 3 over 4 here, 3 over 2. So what I will do with this one, I would just change it that we are working with something the same. So to get to a 4, we multiply by 2, but we need to do the same at the top. So 3 over 2 is exactly the same as 6 over 4. Okay, so then let's take that to that side. So 3 minus 6, 3 over 4x, but negative. Let's take that to that side. So 3 over 2 minus 6. Okay, so what is that? 1.5. And see, that's why I don't like fractions. 1.5 minus 6 is 4.5. Okay, and then I'm now going to use, and it's negative, sorry, and I'm now going to use a calculator to say minus 4.5 divided by minus 3/4, because I'm now not even going to try and work with fractions here, and then my answer is x is equal to 6. Okay, so then if I just look, minus 6 close, so 2, 2, and there is 6. So already we can nearly say our answer will be option 4. But let's just put that 6 back into a formula. So I would actually put that back into that formula. That for now, that I just don't work with a fraction until maybe the last point. So I will have minus 2y is equal to minus 3 times 6 minus 3. And minus 2y is equal to, so minus 18 minus 3 is minus 21. So y is equal to 21 over 2, where it is 21 over 2, which is option 4. Okay, so again, we could have put it into this one, but then I need to work with fractions from the start. I don't want to do that. We could have put it back into this one, but then again, we need to work with fractions from the start. So if you're happy to work with the fractions, by all means do it. I just normally stay clear until the last point, because then at least I know that I can't make mistakes with the fractions until nearly the last point. Okay, so that is just, but you could, and I know some of your calculators actually have nice functions to do it, and to put it in as fractions, but I just try to avoid the fractions until I need to be able to work with it. Okay, so let's go into another question. This was a question, let's just see. Yeah, that was from, I think, last semester, one of the assignment questions, or even the mock exam. So again, please, if you have any, I think I've received some, so I I will include some of it into our session for next week. But if you have any others that you want to share with me, you can share it on the group, and I will pull it into one of our presentations. Okay, so let's look at what they ask us in this one. Consider total revenue and total cost, where Q is the number of units sold. Determine the firm's profit when Q is equal to. Okay, so how do we determine the profit? And so that's nearly the first thing to we need to determine the profit when Q is a certain amount. Okay, so profit, and we've nearly done it in the break even as well. Profit is total revenue minus total cost. Okay, so here again, we don't, and you guys can come in and say the same, but it does not feel to me that at this moment we must do any other thing like differentiation or anything like that. They told us this is total revenue, this is total cost. We need to determine the profit when Q is 25. Okay, so total revenue, what I will do is just move this because it's going to be a lot that we need to write down. So that's the total revenue. Then we need to subtract the total cost. Yes, even if we work now with strange numbers, like a Q to the third, it still doesn't mean that we need to make it simpler by differentiating or anything like that. It's different if they would have asked us marginal revenue or something like that, then we need to differentiate. Here they just looking at total revenue, total cost, and we will need to work out when a quantity is 25, what is the profit. Okay, so let's just rewrite this. Because we've got the negative, I normally just write it over that we make sure that the negative is used correctly. So negative times negative gives us a plus. Negative times a positive gives us a negative. And a negative times a positive gives us a negative. Just that we have that all. So first we've got the negative Q3 over 6. Oh. Okay, so that one is covered. Then let's look at Q2's minus 2 plus 18. So that's plus 16 Q2. Covered that. When we look at only the Q's, 100 minus 164, that gives us minus 64 Q. Let's just do that, and then we stuck with the last one, minus 200. Okay, and then what I will do is put in Q25 in, so it's minus 25 to the power of 3. Where's that on my calculator? Divided by 6. So that first one is minus 2604. They tell us round off to the nearest integer, so we don't need to add those decimals. Then q to the power of 2, so 25 to the power of 2 is 625. 625 times 16. Okay, 10,000 on the dot. Then 64 times 25 is minus 1,600. Then we have the minus 200. Let's hope it gets to that answer. So 2604 negative plus 10,000 minus 1,600 minus 200 is 5596. And thank goodness we got to that. Yeah, so again, if one look at this, there might be things if the sign is different, you get some of the different answers, but this one was just that you needed to know when they ask you to work out profit, what does that mean? Profit is total revenue minus total cost. And then, unfortunately, this is a long question. So there isn't, again, a shortcut for this. But again, when I work with, there's two things that I normally, when I work with fractions, or if I work with something that I need to subtract, I normally just do that extra step that sometimes one wants to nearly work out in your head. I just still write that down because it's very, very easy to make that one sign mistake somewhere, and then you get a different answer. Yeah, so that I just normally always just do that and focus on that. Okay, so let's go into then a question that was also asked, and let's just make this bigger. Okay, and I think we chatted about this one or these types of questions last week, so I will keep the answer in here. So find the turning point of the following function and use the second derivative to determine their nature. Okay, so somewhere in the week we did the normal quadratic function, and then we worked and said, okay, you could use the minus b over 2a, and I showed you guys, and it is somewhere in this pack in any case, that by doing that you could also do differentiation and you get the same answer, but you can only do the minus x over 2a or something like that, or minus b over 2a if you have a quadratic function. Now we have a cube. So cube function we need to differentiate. Okay, so we need to differentiate this function. So when we differentiate, it means the 3 goes to the front, then it's 3 minus 1. So let's 3 times 1 over 3 is 1. So we end up with x to the power of 2. Look again, negative, so the sign going to stay negative. 2 times 5 over 2. So basically, the 2's disappear, so we sit with minus 5x. And then plus 6, there's a 1. 1 times 6 is 6. And when we differentiate, that constant falls away. Okay, so then we basically sit with the formula of x to the power of 2 minus 5x plus 6. Okay, now we need to basically factorize that, or we can also use that function of x is equal to, I think, what is it, b plus minus. So you can use that as well, but looking at the answers, I'm like, okay, there's no fraction, so this should be an easy one to factorize. And we can see, okay, there's a 6, there's a 5, so how to get to a 6? We say, well, 3 times 2. So minus 3 times minus 2 will give us the positive 6. Minus 3 plus minus 2 will give us the minus 5. Okay, so out of this, x minus 3 must be equal to 0, or x minus 2 must be equal to 0. So we can say x is equal to 3, or x is equal to 2. Okay, so that is our 2x point. So if I look at this, then I would have said, okay, there's a x2, there's a x3, x2, x3. Oh my word, okay, so everyone is actually valid. Okay, so that's not gonna help us at, well, not say not gonna help us, but then they say, so there's 5s and 6. 3 is always with a 6. 5 is always with a 2, so that at least tells us something. But when they say, so that's the first component we did. When they say use the second derivative to determine their nature. Okay, so second derivative is when we now derive this further. So this was the first derivative that we took. So let's do second derivative. Okay, and second derivative is when we follow the same process. 2 goes to the front, 2x, then that will be minus 5 is equal to 0. And if we work that out, 2x is equal to 5. So x is equal to 2.5. So what does that help us at all? So let's quickly, I'm going to just make this smaller so that I can quickly just, okay, so we've got the x3. we've got for x2, where we've got for x2.5. So we set that the 1, the 2 was with -5. And so that was, sorry, let's now just do this right. So there's for -5. That's for x2. There's for x3. -6. Okay, so now we need to say, okay, and then there is the 2.5 in between. Okay, so, and let's just put in another point. So that we can see the full picture. Okay, so remember there's also the Y cutoff. Okay, so if we now look at this can't go to that side. It needs to connect to this point. So it needs to connect with that point. Okay? And that point needs to connect to that one. So there we have that one as your turning point. That's your maximum turning point. That's your minimum turning point, and then it goes back and does that. So that is how this graph will look like. But very important is also to see that -10. Because if it was, let's say, let's just draw in another one for you guys. Let's say that was -3. Then it would, I don't know how it would have looked like, but no. Okay, so let's not even go there, because I don't even know how I wanted to to do that. Okay, but so you can see at this point that's a maximum because it can't go higher. At this point it's a minimum because it can't go lower. So that is how, and the reason why we do the second derivative is because it shows you that it's in between these 2 points that second derivative is lying. So if that was now somewhere outside of that, it means that this graph will look also differently. So that's why we also did that second derivative. Was just, it needs to be between your points that you're actually looking at, else it is looking at a way different graph and things like that. So it normally will be that if you need to work out the second derivative, that it will lie between those 2 points. It just might be that those 2 points in other examples are -3 and 7 or something like that. But another thing that you guys can look at, and this is just through experience and looking at all of these questions, what that second derivative, if you work out for x, it's normally the average of those 2 points. So if it was -6 and or -7 and 3, you add the 2 together, you get the average, then that is normally. So you will always always see that your second derivative, if you work out the x value, it is normally the average between the two. And that is just because it should lie between the 2 points. Okay, so let's go into another one. So again, you can see last semester somebody used some of my my questions, and it might have been very similar to get to it. So I can't read that. So I'm just gonna, let's just keep it to that, and let's just make it way bigger. Okay, so very similar type of question. Find the turning points and use the second derivative to determine their nature. Okay, so we can actually now test that theory if it is true. Okay, so I just wanted to check. So first derivative, the 3 goes in front again. So 3 times that is t to the power of 2. 2 goes to the front, so it's minus 4t. 1, so minus 5 times 1 is minus 5. So that will be, so again, we can look at this. We can see again, it is nice numbers, but to get to a minus, so 1 will be minus 5, 1 will be plus 1, and let's just make 100% sure, minus 5 times t is minus 5t plus 1t, so we get the minus 4, minus 5 times that is minus 5. So t minus 5 is equal to 0, or t plus 1 is equal to 0. So t is equal to 5, or t is equal to minus 1. Okay, so we'll do exactly the same. I'm going to do this. Look at that. There's no, so the y cutoff goes through the intercept because there's no y cutoff, so there's no constant. So that means it is plus 0. That plus 0 is it goes through the constant. So let's see t5. So here somewhere is t5. There's minus 1. Let's just see. They already give us all the minus ones with a 3. If we needed to work it out, we would have said put 5 back into the equation. So if you put 5 back into that equation, you would get minus 33. So minus 33, this is now not on scale. So there's the minus 33. Minus 1 with 3. Okay, so now we're sitting with this. There's the y cutoff, which makes it very interesting. And then what we also do, let's look at the second derivative. So what I previously said, it should be those two added, or the average of that. So if I look at that, 5 plus minus 1 is 4. 4 divided by 2. So my second derivative should be equal to 2 if that if that thing is now what we're talking about. So let's just check. Second derivative, it's 2t minus 4 is equal to 0. So that means 2t is equal to 4. T is equal to 2. And so got that sorted out. So this tells me, if I look at this, that is my turning point, and it needs to go through there. Then it goes down. That is where our second derivative is. And now I get to this point. So that means that is going to be the turning point up. This is going to be the turning point down, because I can't turn up from there because then it goes straight. So it needs to turn. Here it needs to turn. So that tells me that point is a maximum. And this tells me this point is a minimum. Okay, so let's see if we had it. There was the minimum, there was the maximum. So exactly the same. So let's just see 5 minus 33 maximum. No. Oh, well, don't know that yet. Minus 1 and 3 is a maximum. Cool, that's right. 5 and minus 33 is a minimum. Cool. So that is definitely correct. Minus 1, 3, and that are both maximums. I don't even think you will be able to, these two will never happen if you have a cubic. So you should, then how do you, I can't even, because when you've got, because when you, I don't even know how you do that, to have both a maximum, because then it also goes, so on a cube, you have two turning points. A cube always, if you have two turning points, well, one must be maximum, the other one must be minimum. You can't have two maximum or two minimum. See, I would always, I would draw the graph just to make it simpler. Let's see if if we don't draw the graph. I'm just thinking on that question now, how can we show this without drawing a graph? So you could see, so still one would look at those and say, yeah, it will be difficult if you don't draw a graph. I'm going to play a bit with, we've got time, so let me play a bit with these things about the maximum, minimum, and see if there's other things that you can identify. Yeah, let me play a bit with it. So the one thing that one can always, so when it's positive, nearly the first one is always a maximum. So you can see it with this graph, you can see it with this graph. So when it's when it's a positive before and yeah, it didn't matter where we were on the graph, that was still a maximum point. So that might be nearly already an identifier for you to say, when this thing is a positive, we know that the first point will be the maximum point. But I will get you guys some steps to nearly identify without drawing, because the guys that were on my stats course as well, I'm visually, so I want to see things drawn so that it makes sense to me. But I will get you guys a few steps to see how you can just look at it, so that you can, when you get those points, you know, this is the maximum, this is the minimum point. But it does mostly have to do with what is that sign in front of that highest, and I think that is also the highest exponent. So again, if they, so I will write you guys down something, because they now might be sneaky and do something like this. And it's exactly the same formula, but then you guys would remember, there's a negative in front, but then it is swapped around. So let me just write some steps down, because I know as well, sometimes you don't get the formula as in we all expect it to look like. But I will do that. That you don't always need to draw. Okay, let's look at this one, because this goes back to study unit 7 and 8. Average cost. Okay, so we now work with, all the time we've now worked with total cost. We looked at demand functions. Now suddenly we get an average cost. And then the question is, okay, now that we have average cost, what do we need to do? So where do we go from this one to get to the next one? So once again, any ideas that you guys have, that what you will do with a average cost? Okay, so let's look at this. So given the average cost for a certain product is this, where Q is the number of units produced. What is the cost to produce one additional unit? Okay, so first we will need to get from average cost to okay, so how do we get from average and right? So how do we go from average cost to marginal cost? So that is nearly, so you're on the right track. So we need to get to marginal cost. So what do we need for marginal cost? We need total cost. And so spot on, we will need to go to marginal cost to work out this change in one additional. So that is where we want to end off. To get to marginal cost, we will need to say we need to get total cost and then we differentiate that. Okay, so how to get from average cost to total cost? We will multiply by Q. So this whole formula, we will need to multiply by Q so that we can get to our total cost. So this is one of those where you are spot on. We will need to get to marginal cost. But to get to marginal cost, we just need to do that extra little step, and that is first work out total cost. And to get to total cost, we just say average cost times Q. Okay, so each of these we will need to multiply by Q. So 6x times Q is 6x to the power of 2 plus 15Q. 150Q divided by Q is 150. Okay, so now we have our total cost function. Now we can say, well, to get to marginal cost, we differentiate our total cost function. So now 2 times 6 is 12Q plus 15Q, and that will give us the marginal cost. So if I wanted to say, wait, that's not Q. So if we needed to work out your marginal cost when Q is 0, then we would put in 0. Here they ask us after 250 units, 12 times 250 plus 15. So 12 times 250 is 3,000 plus 15. Okay, it's weird, but let's see. 3015. Okay. Option 1. And still here, and this was from last year where this was, I don't really like this. But now just be very, very careful. If you have put in 250 in this equation, there will be an answer for you as well, because you can see 6 times 250 plus 15, and if you then set minus, okay, luckily not, so that wouldn't have worked. If we set 250 in that one, that also don't seem possible. So it seems like luckily none of these would have worked if you just put in 250 here or 250 in that one. But spot on, we need to get to marginal cost. How to get to marginal cost is from average cost, multiply by Q to get to total cost. Total cost, we take the first derivative, and that is then your marginal cost. I know in the study guide, I think study unit 6, 7, or 8, there's that nice, nearly the formulas that says go from your total cost, average cost, marginal cost, all those kind of things. So that is a very nice table to nearly have with you guys when you write the exam, so that like this one, where it was now spot on, you need to get to marginal cost, but sometimes one forgets that you can only get to marginal cost if you say, what's my total cost? And then I move to marginal cost. So yeah, so I can't remember on what page that was, but let me quickly, because I can see that that piece in that that table in front of me. Um, I think it was in study unit 6. Yeah, on that first page of study unit 6. Um, mine says um, page 75, but it might also be that I've got a different version. But there is that nice graph: total revenue, marginal revenue, average revenue, total cost, marginal cost, average cost. When it goes into variable cost, marginal variable cost, average variable cost. So that is actually, so in that first page of chapter 6, a very nice table that I think you guys are writing open books, so so you are allowed to. I think you guys are still writing open book. You can just confirm it, but last that I've seen is that you're still writing open book. So you are allowed to have those formulas. I don't think I've sent my few pages for you guys that I've done a summary, so that I will scan today and send to the WhatsApp group as well, that you have. It's just a few pages of summary that you can even write your own notes on it. So I will scan that today and then send it off. Okay, so let's do this one as a last one. Then you guys please can send me more questions. I know I've got one of the previous. I know I've got some questions already that I will add into our next session, and then I will definitely, if you send more on the WhatsApp group, I will add that into more. Okay, so let's look at this one. So simplify the following expression. Again, this is not really part of study units 1 to 8, but again, just to familiarize yourself with that last part of your study unit, the appendix, where they said these are things that you should already be able to do. They can sneak in a question like this. Okay, so here they say, and let's just rewrite it a bit better that we all can see it. So they want you to simplify this expression. Okay, so this is what they want you to simplify. So first thing that I do is that we don't need. We know it's multiplication, so we're going to multiply the 2. And then just so that when there's nothing in that bucket, it actually is just the square root. So it is a 2. Okay, so how I like to look at these, and it just made my life so much simpler when I started working with all these square roots, and I don't even know what to call a fourth root kind of. But to see the square root as a division sign. So how I then see it is x minus 4 divided by 4. Y 3 divided by 4. And then let's just put the brackets for now. The same that divide by x2 divided by 2. We'll look at the 4 now. Y minus 4 divided by 2. Okay, so that is when we work with all these weird fractions and those things. 4, you can work when there's a constant, work it out with your calculator. Square root of 4 is 2. So that whenever you've got a number, use the calculator. Don't even now, because the traditional way is now to say, okay, 4 is 2 times 2. Okay, 2 times 2 is 2 to the power of 2. Now, if you take the square root of that, that's supposed to fall away, and you get 2. This can just create that you make an error. Take calculator, say 4 to the power of, or sorry, 4 square root, you get 2. You sort it. You don't need to now know what the factors of 2 is, or 4, or even if you get 8 or 16 or whatever, use your calculator. So when I then look at this, I always love to do this first. So I see there's nowhere else. So I know it will be 2, and then we will now do things with the rest. But look at this, already 2, 2, 2, one option eliminated. Okay, so now let's simplify a bit. X minus 4 over 4, so that is minus 4 divided by 4 minus 1. That unfortunately stays the same. X 2 divided by 2, that's x1. And then at the bottom, so this one I'm now just first going to rewrite as 1 over y minus 4 over 2 is y minus 2. And so now already we can say x minus 1, x1, that cancels out. Okay, unfortunately that didn't help. But now we sit with y 3 over 4, 1 over minus 2y. So the only thing now we need to really work on is this. What is 1 over y minus 2? So we can, whatever is at the bottom, we can take to the top, but then that sign will change. So that will become y plus 2. So even look at if we set a fraction. So let's say we had that, then we would have, so that is plus 1. So if we changed that so that we don't work with, we would have said, okay, we bring the 2 up front. It was plus 1, but we can definitely see 1 over 2 is not the same as 2. So we need to change whatever that sign was to the opposite. So 2 to the power of minus 1 will also give you the half. So this is what we also can do with fractions. So what we now left with is 2y3 over 4 and y2. So you can now write this in a few different ways. You can write, and you can write that as 2y 2 3/4. You can write that as 2y, and we do everything as, what is it? Do we call it an improper fraction? I think 4 times 2 plus 3 is 11. So we can write it as that. Is there another way? So that is basically the two ways that we can write it. So we can then just check, okay, which one of those are in my answer set. Okay, so there was a 11 over 4, but that was wrong. 3 over 2, so no. 5 over 4, so no. Ah, great. 2y 11 over 4. That is our correct one. Okay, so again, I might throw in these because it's assumed that you guys should know it because of that appendix that is at the back. So just again, while we do prep next week, I will throw in a few extra ones for you as well, just to make sure that we do cover everything. Awesome. That's it for today, everyone. So once again, really thank you for joining on a Saturday morning. I know it's been a bit crazy with everybody writing on Saturdays and things like that. But yeah, thank you for joining.